Good morning, students. Welcome to the lecture of mechanical vibration. This is the subject code ME502, and we are starting today the unit 1, that is fundamental aspects of vibration. This comes under a 5th semester RGPV syllabus. My name is Professor Jawalkar. I'm starting the lecture of mechanical vibration. So first of all, we have to discuss what is the vibration. So before describing the vibration or before defining the vibration, we must know that in the whole mechanical or in the whole technical field, the engineering field, there is a force and material associated with the uh, each and every machining component or the jobs and components. So all the bodies having some mass, and due to the mass there must be some force, and due to that force there must be a uh, unbalancing force which act on the body. So all the bodies having mass and elasticity are capable of producing vibration. So I'll let you know that supposed to be there is a you're riding a bike, and the ride in the riding of bike there is a unbalanced forces due to the unbalanced mass center, changes in the center of gravity, and the elasticity of the material. And the elasticity of the material, there must be vibration in the uh, riding a bike. So whenever there is a mass, unbalancing force must become, and there is a motion, unbalancing force must become, and due to the material characteristics, there must be a elasticity which is capable to producing the vibration. Now the second point, when body particles are displaced by the application of external forces, the internal forces in form of elastic energy are present in the body. So when the body particles are displaced, as I told you, the mass imbalance or elasticity, I can say that there are a number of particles which are displaced from their original positions or in the resting position due to the application of external force. The internal forces in form of elastic energy are present in the body. Thus, any motion which repeats itself after an interval of time is called vibration or oscillation. So I'll give you an example of a watch, the clock. I can say that the watch which we are using before some time, before 10 years, we are using a clock in which there is a oscillating pendulum. I can say that there is a pendulum which oscillates from one position to another position, and it repeats its motion. And this motion is generated with the help of springs or diaphragms. Now, if there is a motion, that motion indirectly transferred or directly transferred to the gears, and that gears are associated or connected with the needles, and the needles shows us the timing. So this is one of the example of the vibration. That vibration is transfers the energy, and this energy is created due to the oscillation, and this oscillation is called vibration. So vibration gives us the time in the watches, or in many field vibration is useful also. So the vibration can be defined as the motion which repeats itself after an interval of time, or it is also called oscillation. Now the next point, vibration can be defined as simply the cyclic or oscillating motion of a machine or a machine components from its position of rest. So we can consider that the machines are in running condition. So before going to run, the machine is in rest condition. As as I told you, there is an example. You suppose that you are riding a car, but before riding a car, it is in a static condition. If the car is in a static condition, there is no motion. Whenever you are changing the speed, or whenever you are increasing the speed, or the car changes from rest to dynamic condition, there must be a vibration. So vibration can also be defined as this, as simply the cyclic or oscillating motion of a machine or a machine components from its position of rest. Whenever we are changing the rest position, there must be a vibration in a machine. Now the next point, an important class of dynamics concern the linear and angular motion of bodies that responds to the applied disturbance in the presence of restoring force. So in the dynamics, we have already studied that whenever there is a dynamic motion, the body tends to uh, restore its forces. So due to that, the dynamic concern, the forces restoring capacity is also called vibration. Due to the restoring forces in the machine, in the dynamics, there is a vibration comes in picture. Now, some of the examples of vibrations are uh, response of building structure to an earthquake. So, if we can consider an example of earthquake can be can be considered with the help of unbalancing or vibration of a building structure, unbalancing axle rotation. So, so in the case of unbalancing axle rotation, there is a vibration. Flow include vibration of a car, as I told you. Flow induced vibration of a car body, and the rattling of tree levels, etc. So these are some of the examples of vibration. Now, how many types of vibrations are there in the machines or are classified? So, vibration sources are characterized by their time and frequency domain properties. So, categorize if we are categorizing the vibration, so there are two types of vibration: periodic and random disturbance. So, these are the two causes, or I can say that these are the two factors by which vibration can be generated. So, in periodic, originated from the HVAC, DG fans, etc. This is related to the electrical field when there is a high volt AC current or DG fans, etc. produces vibration. Simplest form of periodic disturbance is harmonic. So in periodic, there is a harmonic vibration generated. In the time domain, this is represented as a sinusoidal, and in the frequency domain by a single line spectrum. Now, in random disturbances originated from footstep sounds, conversion, etc. So, periodic vibrations and random vibration. Random vibrations are originated from random activities, that is, footstep sound, due to the footstep sounds, conservation, etc. There is a random vibration generation. Only static representations are possible. So in random disturbances, only static representations are possible, generally represented by its power spectrum. So this can be represented by its power spectrum. As compared to periodic category, it is represented by a single line spectrum. But in case of random disturbances, it is represented by its power structure. So these are the differences, or these are the categories of vibration. The generation of vibration can be generated periodically or vibration can be periodically or uh, random due to the disturbances. So this is all for today. I hope you understand today's lecture. In today's lecture, we have covered the introduction of vibration, what is a vibration, how it is generated, and what are the types of disturbances that can be cause the vibration. So thank you very much for today's lecture. In the next lecture, we will cover the next